Hello, welcome back where we're working on the topic of writing quadratic equations or parabolas when we're given the roots. When we're given the roots as a starting point, how do we go backwards and reconstruct an equation? Usually that has those roots. Usually we're trying to find an equation with integral coefficients. So in the last lesson we introduced the topic, we talked about the theorem, we talked about exactly how to do it, and we did an example. But that was an easier example because the equation that we got out of it already had integral coefficients. But the theorem actually tells you that when you get the quadratic back from this process, this is what it's going to look like. You're allowed to take that quadratic and multiply it by any number you want, and you're guaranteed that the resulting quadratic that comes out of that is going to have exactly the same roots as the one you started with. And we talked about why that is in the last lesson. So if you haven't watched that, go back and watch it. So an easy to remember way to figure this whole thing out is you have to know the sum of the two roots, the addition of the two roots that you're given, and you have to also know the product of the roots. Once you know that, it's just x squared minus the sum of these roots times x plus the product of these roots. That's the base quadratic. And if you ever get a quadratic back from that process that has a fraction in a coefficient, like a fraction in front of the, any of the terms, then what we always want is we want integral coefficients. So you might have to multiply through and clear any fractions away, and that's where this comes in. I'm allowed to do that. I don't have to do that, but I'm allowed to. All right, because this A basically means an entire family of quadratics exist that have the same roots, R1 and R2. So this is a good example of when you're going to need to do that. So if I give you and I tell you that the roots of some quadratic are -2 and 5/2, and I say, give me a quadratic with integral coefficients. Notice I'm not saying give me the quadratic with integral coefficients because there's not just one of them. There's a whole infinite family of them that have these exact two roots, right? But I just want to find one of them. And so what I'm going to do is follow this exact equation. I'm going to find the sum of the roots, I'm going to find the product of the roots, and I'm going to stick it in here. And we've already discussed where this comes from in the last lesson. Right? So here's where you have to learn or use a little bit of fraction. So R1 plus R2, the sum of these roots, R1 plus R2 is what I'm trying to write, is going to be -2 plus 5/2. You have to know how to add these guys, right? So the easiest way to do it is to say, well, I'm going to put and write this as -2 over 1, and I'm still going to be adding 5/2 to it. But I'm going to multiply this by 2 over 2. Why am I doing that? Because I need a common denominator to add them. So what I'm going to get here is -4 halves plus 5/2, right? And then, of course, when I do this, I can say that I'm going to have -4 plus the 5, which is 1, and then the common denominator comes along for the